I request everyone, you can check. Meanwhile, I'm discussing the conceptual aspect of the descriptive of the chi-square test, right? So give me a second. I'm going to share my screen. Hello. I hope I can start, right?
Yes, ma'am.
Yes, ma'am. Please start.
Sure,
Fine.
ma'am.
Fine. Thank you. So I'm sharing my screen. Give me a second. Okay, I think I shared my screen. It's visible, everyone. I'm showing you the Excel sheet.
Yes, ma'am. Visible.
Fine. Thank you, sir. So yesterday we have seen descriptive statistics. We have understood the concepts of skewness and kurtosis and its importance in terms of normality, right? Today I'll talk about non-parametric test, that is the chi-square test, right? So I'm writing the name chi-square test, right? So chi-square test is a non-parametric test, or I can say in statistics there are several kind of statistical tests available. We can classify them into the two categories: parametric test and non-parametric test, right? So here, when I talk about chi-square test, this test comes under the non-parametric test category. So question comes, what is a non-parametric test, right? Anyone is having any idea about the non-parametric test? Yes? Anyone?
Generally, the sample size is smaller. You can say up to 30.
Okay. Okay, fine.
Ma'am,
Anyone?
used for continuous data.
Used for continuous data. Fine. Okay. Any other answers? Yes? Anyone else? Any idea about the chi-square test? No?
I mean, it is normal distribution, a
Okay. So now,
bell-shaped curve.
uh, uh, Sneha, ma'am, you're talking about for the non-parametric test, right?
Oh, sorry, ma'am.
Okay. Okay, fine. So that means it is not the correct answer. This is what you are saying, Sneha, right?
Yes, ma'am.
Yeah, fine. So I think I'll discuss the non-parametric test. Non-parametric test, generally, it is a test which is not bothering about the normal distribution, specifically normal distribution, right? And when we have categorical variable, we are using the non-parametric test, right? Generally, when we are not bothering about the whether what is the distribution of the population, whether the population is normally distributed or not, or we have extracted or taken the sample from the normally distributed population, in that case, we can go for the non-parametric test. Also, when the variable nature is categorical, right? In that case, also, we need to use non-parametric test. Is it clear? Is it clear, friends?
Yes, ma'am.
Fine. Now, when I say chi-square test, there are two types of chi-square test. The first one is known as the goodness of fit chi-square test, right? Generally, in this chi-square test, we will be having one categorical variable. Second one is the independence of attributes or test of association, in which we are having the two categorical variables, right? So when I say goodness of fit test, that is the first category of the chi-square test. Here we are assuming, or we want to find the uniform distribution of frequencies. How many of you have worked with chi-square test previously? Yes. Okay. Any answers? No one has worked with previously with the chi-square test? Yes.
Ma'am learned it before, but never really worked on it.
Okay, fine. No issues. Fine, ma'am. So anyone who has means in statistics, if any one of you have studied chi-square test? No? Okay, Jasmine, ma'am is saying, I think yes. Okay. So, okay, fine. So, do you have idea about the formula which we are using for the chi-square test? Anyone? Any idea?
No, ma'am, no idea.
No idea. Fine. Okay, so means you people are very new to chi-square test. Fine. So, I think I'll discuss this. So, when I say chi-square test, here in case of chi-square test, the formula is generally there is Greek letter, I think, which is we are using to represent chi-square. We can say chi-square is equals to sum of O minus E square divided by E. This is the formula which we are using, right? So here what is, because only two things we can observe here in this particular formula, that is O and E. So O is observed and E is expected. Right, so observed and expected frequencies, these are the notations, or what we can say, these symbols are, and in the meaning, these two symbols are meaning like observed and expected frequencies, right? So that means when we talk about chi-square test, this is working on the frequencies, right? Means the counts. It is not working on the values, as we have understood that generally variable is the entity which is accepting various values. So when I say a categorical variable is generally accepting the counts or the frequencies, right? So for example, I want to count how many of the students are interested to study a particular subject online, right? So that way I can maybe bifurcate students firstly on the basis of their gender, that how many female are saying yes, many male are saying yes, and that way we can get the count. So this can be one of the example, right? So when I say goodness of fit chi-square test, is in this we will be having only one categorical variable, and there for all the categories of the categorical variable, we want to see whether the distribution of the frequency throughout all categories is same or not. This is the purpose behind the goodness of fit chi-square test, right? So for example, if suppose I have asking you lacking of the subject, right? Suppose I have given certain choices. So suppose I have written here science, suppose maths, maybe Hindi or English, history, for example. These are some of the subjects I have given as a choice, and I'm asking people give your choices. I think English as yes. So these are the choices we have given to the people and asking which subject you are liking most, right? So suppose I'm getting 23 are saying they are liking science. Suppose 12 are saying they are liking maths. 15 are saying they are liking the Hindi. Then suppose 30 are saying they are liking the history, and suppose 40 are saying they are liking the English, right? So this way, this is the data, this is the count or the frequencies given to us, or we have got, right? So these frequencies are known as the observed frequencies, right? And we want to see whether the distribution of all these frequencies are same for all these 5 subjects or not. This is what we are looking in the goodness of fit chi-square test. Is it clear?
Yes, ma'am.
Yes, ma'am.
So when I talk about its hypothesis is generally we are formulating in the form there is no significant difference in the observed and expected frequencies. This is the null hypothesis we have made. Suppose I want to write the alternative hypothesis. I think everyone is knowing this thing. For every null hypothesis, we will be having one alternative hypothesis so that I can write there is a significant difference in the observed and expected frequencies of the subject's liking, right? That way, this is the hypothesis we have made. So we need to test this hypothesis using these observed frequencies. So this is known as the goodness of fit chi-square test. I hope till here I am clear. May I proceed for the next test?
Yes, ma'am.
Yeah. Next in the chi-square test category is the independence of attributes. Or other name for this is test of association, right? So now here we need to see whether the two attributes are independent to each other, or maybe we can say whether the two attributes are associated or not. So when I say categorical variable is representing generally the characteristics of any object, right? Or attributes of any object. So we need to see whether the attributes are independent or they are having any association, right? So when I say second type of chi-square test, which is independence of attributes, here we will be having the two categorical